Okay, it's almost time, so let's see. Testing the microphone. Okay, so hello, this is Junichiro Horikawa, and this is the weekly tutorial live for Houdini, and this is the 89th episode. And the topic for today is to create this creature-like procedurally animated so I'm calling this Venom ball. Looks like a creature. So this is what I'm gonna create today from scratch, and let me explain how this can be done. Now this is not restricted to a ball shape, but you can also use a shape like a custom shape like this one, like a peg head. So instead of having a ball as a base shape, you could also use a any kind of input mesh for this kind of simulations. Now you do need to have a little bit of tweak to make it a little bit looks nicer, like controlling the shape like these. So it's not really based on a physics simulation, it's just the procedural stuff. Everything is done in procedurally using just the simple vector mathematics. So the update is pretty fast, I think. Right, so that's what I'm gonna show you today. Okay, so first of all, what I would like to do is to show you the very base algorithm underneath this one. Okay, so basically it's pretty simple. It's just Voronoi Fractures moving the cell around using the base center points, and then connecting some of the cells together, like stitching the cells together to make it like a liquid-like shape. So first of all, you plot several points on top of input geometry to create the Voronoi Fractures like this. And in order to animate this, you just need to move those points randomly. I mean, maybe you could also move those points based on some force field of your choice, but in my case I'm just moving this randomly using like Coronoid vectors. And by moving the points, and for every time you move the points, you update the Voronoi Fractures, made it possible to create a simple Voronoi cells animations. And what I'm doing additionally is to connect some of the cells together, like getting rid of those walls in between the cells to create a more of an organic shape rather than having a circular cells. Okay, and after that, after you have got these profiles of those cells, what I'm going to do next is to calculate the distance for each point on top of the mesh. For example, this mesh is constructed with tons of triangles. More triangles you have, more high-res geometry you could get. And for each points on the triangles, what I'm going to do is to calculate the distance to the closest edge of the Voronoi. So this is the points, and for example, let's say I want to calculate the distance from this point to the closest boundary edge. Maybe the closest edge is somewhere around here. So you calculate this distance for each point and store that information to each point for every point on the mesh. Then later on use that information to extrude the create a mountain or hill to those surfaces using the normal directions, so like that. Now in order to make it like how do I say, like a pumped up shape, like a liquid shape or like a balloon shape, I want to make something more like this kind of shape instead of just a mountain shape. So what I'm doing here is to, after I have created this hill shape, I'm retaking this normal direction, then re-extruding or removing the surface based on this normal directions together with some ramp parameters or ramp curve. As a result, you'll be able to get this kind of liquid-like shape on top of a surface. Okay, so that's what I'm going to try to do here. Hello everybody, thanks for all the comments. Multivision Rangerel asked me, could you do a live webinar for Rhino Compute, please? Yeah, that'll be interesting. I do like dealing with or using Rhino Compute, and I haven't been touching it for a while since the last update of Rhino, so maybe that's one interesting things to do. Yeah, I think I might do that as well. Okay, so let's do this from scratch. I'm gonna move this upward, and let's see how do I do this. Okay, so first I'm going to create a geometry as always, and I'm gonna start by using a simple shape like sphere. It's the most clean shape to test out. So let's do this. Okay, so instead of polygonal mesh, I'm gonna make this to a icon sphere, and let's make the frequency higher so that I can have enough resolutions to make the geometry high res. Maybe I could make this like 50 or 60 to have enough points on a sphere like this. So I now have 36,000 points. Okay, I think that's enough. Now next thing I would like to do is to create some points moving on top of this surface randomly, and use those points to be a center of the Voronoi core. So to do that, I am going to create initial points using scatter points, and let's make the number of points not too much for now, like 30 points. And I think it's a good idea to control these parameters later, so I'm gonna create a null node named as controller to store all the parameters that I want to control later. So for initially, I would like to create a number of points, or number of cells in this case. Right. Let's set the range from 0 to 300. And I'm gonna make this to 30 for now, and let's paste that to here. Alright. Now next thing I'd like to do is to move this point based on some noise functions. I can do it either in procedurally using like a noise functions, or make it moving more randomly using a solver. Either way is fine, I think. Maybe I'm gonna use a solver in this case to move the points on top of the surface, so that I can have more random movements. Okay, so Let's also give a null node in between the geometry and the scatter node, so that I'll be able to replace the geometry easier later. Okay, and I am going to connect this geometry to the second input of solver, so that I can ray those points always on top of the surface. Okay, now looks good. It's time to go inside the solver to move the point whenever you want, however you want. I'm just gonna make it simple. I'm gonna create a curl noise vector value to move the point anywhere in the space, then ray down to the original surface so that it won't go outside the surface. I'm gonna use the point wrangle, and let's create the moving vector using the curl noise. And since I want to make it animated, I can use frame value, I guess. Let's see, but maybe not. Since I'm using a solver, maybe I don't really need to make it as animation, but let's see. So first parameter I could use is the point, the current point positioned, obviously. And let's multiply it by some values to control the smoothness of the noise. Maybe I can parameterize this. And also based on the point number, I can make it as a seed number, seed value for the curl noise. So let's multiply this by a really large number, like 10,000. Okay, this will give you a vector value which moves on three-dimensional space. Let's check this out. I'm gonna visualize this with the tag here. To show up the vector direction. Yeah, it's moving some random direction, as you can see here. Now, what I want to do is to use this one to move the point, the current point position. So, and also let's also multiply this moving vector by some moving value, like how much you want to move. So you can say this is a speed. Let's say the smoothness is 0.01 and the speed is 0.03 for now. And what I want to do is to move the point to this moving direction. And let's see what happens. I'm not sure if you can see the points. Let's make the point radius a little bit bigger. Okay, if I play it, now the point is moving, spreading to the space. That's not really what I want. I want those points to stick to the surface. So let's use the ray node to fix this point position on top of the surface, and the surface is coming from the second input, so connect it like this. Project to minimum distance for the points. Okay. Right, now the point is moving, but at some point it just stops, so maybe I do need a little more values for the curl noise parameter. Probably it could be a frame related value, so let's add the frame value, the current frame, multiplied by some another, I don't know, speed value. I'm gonna call this time. So multiply by 0.02. Let's see how it goes. Now it starts to move more interestingly. Yeah, looks interesting. A bit too fast maybe. If I change this to 0.01, looks nice. Yeah. Maybe 0.02 is fine. Okay, so this is what I've got in terms of the point, it can be any kind of movement, just using Coronoids right here, but it could move based on your like vector field, volume field, anything you choose, any of your choice is fine. It's maybe based on the curvature or the principal curvature or the gradient of the surface. That also could be interesting, but for now I'm just gonna make it random. So now that I got this random moving points on top of the sphere, it's time to create a Voronoi shape. So let's do this. But if you try to make a Voronoi shape out of this high-res geometry, it's gonna be too slow. If I try to use this, and I just need the surface, so I don't really need to create the interior surface. Now if I try to create the Voronoi fractures out of this high-res things, you can see that this is too slow. So for the fracturing part, I'm going to use the low-res version of this input geometry. So in order to do that, I'm going to remesh this original geometry to some low-res version like this one. I think this is still fine. Okay, so let's try to create the Voronoi fractures for this one, which is the target size of 0.2. This could also be parameterized as well. So let's open up the edit parameter interface and drag and drop this target size here. And let's rename this to Voronoi remesh. It's not really straightforward as the name, but and we could also bring these parameters as well in order to control the speed of the points. So I'm going to create a separator here, drag and drop these parameters, and I'm gonna name this noise smooth, noise speed, and let's call this noise time. So controlling these parameters, you'll be able to control the speed or smoothness or the speed of the point moving on top of the surface. Okay, going back, what we want to do is to create the Voronoi fractures of this low res version of the geometry using these points. Now if I play it, it's much faster. That's good. And the reason why it's okay to use the low res version is because I just want to use the outer lines, and we could also project this outer boundary of the cells to the high-res versions, and that's still fine. That still do the job for us. Okay, so in order to get the outer boundary of each cells, first we need to get rid of those inner edges. So I'm gonna use the divide node with the remove shared edges. Hi, Aaron. Yeah, this tutorial live is going to be recorded, so you can always go back to watch it together with the saved file from the description page. So you're always welcome to come back. Okay. So now that I have dissolved the inner edges, let's try to get the outer edge or a boundary edge by using, in this case, let's see what I can use. I can use a polypath in this case, I think. Polypath will create an edges out of these geometries. And right now we have these edge curve for each cells. Sometimes it's disconnected. No, it looks like disconnected, but I think each cells has its own curves. Okay, now is that fine? Yeah, I think it's fine. It's not a big problem. Now, after having this one, what I'm gonna do now is to wait a minute. It might be a good idea to just fuse the divided geometry so that I can have less curves. Yeah, so now by fusing it, I now have each edges as separated geometry, like primitive. If I check it, yeah, it looks like this. Okay, so it looks fine. Now as you can see, right now the resolution of these boundary edges is not that high. It's because it's coming from the low res geometry. So let's make it high res by resampling it and project it to the original surface using the resample node. Resample node. Make this high res enough. 0.05 or I don't know, 0.03, 5 is fine. Okay, now in order to project this on top of a original geometry, what I'm gonna do is to use the ray node. Using the ray node to the original geometry and use the minimum distance. Okay, now the point has been projected to the surface and it looks pretty smooth now. Okay, now one thing I could also do is to make these edges on the corner to be a bit smoothed out to make more smoothed profile of the liquid hill shape. What I can do is to use the smooth node after resampling it with really high number of iterations or strengths. So let's say if I make this strength up and to 100, do you see a difference? Not much difference, is it? It's not much difference. I see not much difference here. Maybe it's not really useful in this case. But I think it will be after you have like removed the edges in between the cells. But for now, let's just remove this since it doesn't do anything right now. Okay, now that I have these profile here of the curve, it's time to calculate the distance from each of the points on the mesh to the closest calculate the closest distance from the vertices on top of the mesh to those boundary edges. And you can easily do that by you can also calculate the closest distance using the ray node, I guess. So shall we do that? We could use another ray node, and for each mesh, each points on the mesh, we want to calculate the ray to those edges using the points with the minimum distance, and we actually don't want to transform the points. We just want to calculate the distance. And in order to calculate the distance, I think there were some options. Calculate the distance where it touches to the closest primitive. So point intersection distance, and if I look at the geometry attribute, now you see that there are distance values stored in each point. Now let's check what kind of values we have here by coloring each point based on those this attribute. I'm gonna use the color node for points from ramp from attribute, use the distance, and the maximum was about 0.2, so point. Now this is what I've got in terms of the distance. You see on the edges you get value 0, value 0, which is close to black, and on the center you got some white value which is close to 0.3. Okay, so I can use this value to raise up the points to the normal direction to create like a hill-like shape. Now the problem is here is that right now the edge, you can still see the edge from these values, so it's a bit like a hard surface like values. If you directly use this distance value to extrude the points to the normal direction, you see kind of a hard surface like shape. Let's try that out. In order to do that, I am going to use first of all calculate the normal direction just in case for each point, and or maybe I don't have to do it right here. I can just do it before connecting the geometry to the geonode like this, since we're not really modifying the original shape right here. Okay, so let's use the point wrangle in order to move the points based on the distance value to the normal direction. How do I name this? Move or mountain? Okay, now let's try to do this. It's pretty simple. First of all, you need to get the distance value out of the geometry attributes or point attributes. Then move the points based on this distance value. So to the normal direction, multiply by this distance value, multiply by some multiplier to control the maximum height. Okay, so if I increase this value, you see that you now have extruded points based on the distance value stored in each point. If you move this, you are starting to see some animations. Now this itself is interesting, but as you can see, what I don't like is these hard edges here on extruded geometry, so that's what I want to fix next. Now in order to fix this one, and also right now you can't really like determine the actual height of the surface. That is because it's based on it's totally based on the distance. So if you have more points for the cells, like 200 cells, the height will become smaller because the distance will become smaller on the center. So if you want to have a constant height value for the geometry, you do need to normalize the distance value somehow. So let's do that first, so that I can use the same height value for any number of cell points. Okay, so in order to normalize the distance, the easiest way is to just get the maximum value of this distance. Right after I calculate the distance, I can use the attribute promote for each point, check the distance, and get the maximum value and store it into detail. Just like this. By doing this, you'll be able to get the maximum distance out of all the points, and then use this to normalize the value somehow. In here, I guess. So let's do that. Let's get the max distance as well from the detail. And then by dividing the d by max d, you'll be able to normalize the value, the normalized distance value from 0 to 1. Normalize meaning you remap the value in between 0 to 1 in this case. Okay, and by doing this, it'll be much easier to control the height, because you know that the value is in between 0 to 1 now. The value is always in between 0 to 1. So this actual move parameter is going to be the actual maximum height of the geometry, this geometry. Okay, so if it's equal to 1, then that's the maximum. No, I gotta multiply by f. So if it's equal to 1, then the 1 is the maximum height of the mountain, and whether you change the number of points to 200 or 30, you always get the same height as a maximum value. Okay, looks good. So now the height looks good. It's now time to smoothen out those edges to make more round shape, more like a liquid shape. To do that, the easiest way I could think of is to smoothen out the distance value, which is stored inside after this ray node, this one. So right now you can see that you can still see the edges from the color. So by using a blur functions, you can smoothen out those values on top of the surface. So in order to do that, I'm going to use the attribute blur node for a distance attribute, and more blur you have, you see that more smooth value you get. Okay, so let's determine how much blur value we want, and let's also check it with the actual height. Connecting right here, and you can see that how these attribute blur is controlling the smoothness or sharpness of the surface. Now this might be a good value for the parameter, but let's fix this to 20 for now. I'm not sure if it's a good idea to make this parameterized, because I found out that fixing to some value like 20 is always good for any kind of shape. But let's check that out later. For now, I'm gonna make this fix to 20. Okay. Now, next thing I'd like to do is to, right now it's still like a mountain, like needle ball here. So what I want to make is more like a liquid-like shape for each cells. So in order to do that, I'm going to recalculate the normal of this surface and remap moving, recreate the surface by using this normal direction together with the distance value to create another mountain shape. Okay, so basically what I'm doing is pretty much the same as I'm doing right here. I'm just doing the same things again, recalculating the normal direction for each point, and then calculate or do the mountain again. Now you start to see some shapes coming out like a liquid, more like what we were looking for. Now it's still not it doesn't look like a liquid. I do need more like inflation like shape for this geometry. So to do that, I'm going to use the ramp parameter to control the shape of this mountain. And in order to do that, I'm going to use the ramp parameter for this one. So ch ramp, and I'm gonna name this just ramp for this f value. Since f is in between 0 to 1, we can just use this like this. And I think I am missing something here. Okay, so replacing or remapping f with this ramp parameter, and currently the default value is the linear curve, but by making this like a rounded shape, you start to get more like a bubbly inflated shape like this, which I was looking for. And for the bottom part, maybe we could make something like this to have a little bit of curve here. Okay, can try those curves to see the difference between the shapes. Okay, looks good. And if I play it, it already looks like an interesting curve or an inflated motion or liquid motion. Okay, how's this? Right. Now, what you could do, I mean, you could also use this ramp parameter for the initial mountain that I have done here. So maybe I can replace this with this one and see what we got. Now we have more control over the shape. First we could create the inflation of, first we can create this mountain shape using another type of curve ramp parameter, and then based on this one I am inflating with another ramp parameter. Now that's a bit much to that might be a bit much to control, but this will enables you to control a lot in terms of this shape, and looks nice. It already looks nice. Okay. Now it still looks, I mean, at this point it looks fine to me, but one thing that I didn't try, I want to try, is to make the shape of the cell a bit more organic, because right now it's still a direct visualization of the Voronoi cells, so each cell looks pretty much circular. To make it more organic, I thought that it might be interesting to connect several cells together, several cells together to create one big island, to make it more like liquid-like shape, or water drop-like shape. So that's what I want to do next. Just delete this. Now before going to that direction, let's bring those parameters to the controller so that we can use this. We can use these values to change the shape later. Okay, so we have two steps. Two mountain steps, 1 and 2. The name is different, but so let's bring the first one to here. Let's name this mountain value 1, or just say mountain 1, or mountain move. And also drag and drop this ramp parameter. I don't have to show the control by default. And let's also name this mountain ramp 1, mountain ramp 1. And let's also bring up the second one, mountain move 2, and mountain ramp 2 and mountain ramp 2. Right? So let's click apply and let's check that we could control these shapes. Later. Okay, looks good. Looks good. Maybe I forgot to make this unchecked show controls by default because it's not necessary to show those controllers for the ramps. Okay. So going back to where we were creating the Voronoi edges, somewhere around here, what I want to do next is to remove some of the edges, which is connecting cells together, stitching cells together, and make it as a big island. Okay. So in order to do that, what I am going to do is to create a clusters to each cells. I'm going to set the cluster ID to each of the cells. For example, I'm gonna draw this in 2D, but let's say we have Voronoi fractures like these, and what I'm gonna do is to randomly set a cluster ID to each of the cells. Let's say from 1 to 3. So this could be 1, this could be 2, this could be 1, this could be 3, 1, 2, 3, 1, and 3. Okay. Now, what I would like to do next is to, if we are having the same cluster ID in the neighbor polygon, then we're going to remove these edges. If we are having 2 and 2 in the neighbors, we're going to get rid of these edge that's separating it to make it as a one whole big shape. If the neighbor cells have different cluster IDs, then just use this original like edges as it is. As a result, you'll be able to create a bit more organic shape. So that's what I'm going to do. I'm going to try to set the cluster ID, then the cluster ID won't change when we move the points around for each point. So sometimes it gives you a connections between the cells with the same cluster ID. Sometimes you have a separate ID based on the point positions. Now that's what would happen. So let's do that. So initially, before moving the point, I want to set the cluster ID. Okay, so right after I have created the points on top of the surface, I'm going to set the cluster ID to each of the point. And what I need to define is how many clusters do I want to define. Like right now, the total number of points is 30, but if I set the number of clusters to 30, then there's less chance to have a neighbor polygon to share the same ID. But if I make the total number of clusters to be 2 or 3, then there's bigger chance to have a same ID on the neighbors, meaning you have more chance to have a great or bigger island shape. So that's another parameter to choose. Let's set the cluster ID by setting as an attribute. So I'm going to set the integer attribute named as cluster with the random value coming from the current point position, multiplied by the total number of clusters, and since we have to make it as an integer, let's use the floor function. Okay, so this value, this number of clusters value will be the total number of IDs, and make it less, you'll be able to have greater, like larger island connections between the points. If we have larger number of clusters, then you have less chance to have a bigger island. So let's make it like 3 or 4 for now to see the effect, so that you have a bigger chance to have the same IDs on the neighbors. Let's check that out by creating another label for the cluster. Okay. I think I'm not seeing it. Is this because, okay, I do have a cluster. Cluster. Oops. Okay, it is showing, but it's a bit too small. Let's make this larger. Still hard to see, but yeah. So you see that in total you have 3 different numbers, 0, 1, and 2. And if we are sharing the same numbers on the neighbors, then neighbor polygons or neighbor cells, then we're going to connect them as one cell. And what I want to do is to keep these numbers while it moves, and it does like that with the solver, so that's okay. Now, after creating the Voronoi fractures, we still want to keep these numbers of cluster values to each of the cells, so that we can use that information to connect the cell together. So we gotta think about how we can transfer this value to each cells. Okay, so to do that, I think I need to check one options for the Voronoi to maintain the point number or piece numbers by setting this options, maintain piece numbering, so that the number of the point and the primitives won't differ. Okay, and another thing I could do is to going into the geometry spreadsheet and looking at the primitive values. You see that you have a name attribute being created for this Voronoi, which indicates the number of points coming from the solver. So what I could do is to use this information to use it as a point number to get the information from the cluster, from the solver to get the cluster value. So I don't really need the string piece, I just need the value on the right hand side, this number value 0, 1, 2, 3, 4 and so on. So I could just go to this Voronoi setup, Voronoi parameters piece prefix to make it empty so that I can just have these number as it is. Now this is still a string value, so we need to convert this into integer to use it as a point number. So let's do that. I'm going to connect this, and actually I do need to use the primitive Wrangle instead of the point because the name is stored in the primitive. Okay, so change this to primitive Wrangle and let's name cluster transfer. Now first thing I want to do is to get the point number from the name, so we could get the s at name, and since this is a string on a primitive, we want to convert this into an integer by using a toI function. Okay, now that I have got the point number, it's time to get the corresponding cluster value from the solver. So connect this to a second input, and if I look at the solver, at the point, you have this cluster value. So right now I have got these point number corresponding to the Voronoi piece. We want to use this number to get the corresponding cluster value. So cluster is equal to point from the second input, get the cluster value at ptnum. That's it. And then transfer this cluster to the primitive like this. And now each primitive has this cluster value transferred, and it's still preserved even though I after did this divide node to remove the edges. Maybe, yeah, I think so. Yeah, so, and also it still keeps its value. Now this is where I want to use this cluster value. So by using the wait a minute. Okay, so before doing the divide node, so since divide node will create a, in this case divide node is using to remove the shared edges, these inner edges. Now what we want to do is to also remove those edges, which is using as a wall to divide the cells. And if the connecting cells or neighboring cells shares the same clusters, we also want to dissolve this shared edge. So in order to do that, we could use this another fuse node, only connect the points which shares the same cluster value. That's what I would like to do. Okay, so in order to do that, we could use this fuse node, and there is a option to use the match attribute. So if the attribute matches, then you can connect the unconnect or unweld points together. And by connecting the points together, you can make these edges as a connected edge, which means it's going to be a shared edge and can be dissolved. Now we actually don't have the point attribute yet in order to determine the clusters, because right now the cluster value is inside a primitive. So what we want to do next is to transfer the cluster value inside a primitive to the points. And in order to do that, we can use the attribute promote to promote the value from primitive to point. Don't delete the original. Okay, by doing it, you can connect the points which is coming from the primitive, which shares the same ID. And as a result, using the divide node, you can actually dissolve the edges which shares the same ID in the neighbors. And if I look at the poly path, you can see that edges has been dissolved if we are sharing the same clusters. Okay, let's check this if it's correct. So going back to the solver, show up the cluster values, and you see that I can see that this whole shape is based on the cluster value equal to 1. This region is cluster equal to 2. This region is cluster equal to 0, and so on. So I think this is correct. Now, everything looks good. And going back to the original going back to the final output, and you'll start to see an interesting shape happening. You can see that the shape is now has a bigger island. You see some jumps between the shapes of the mountain, creating more like a liquid-like movement. And you can change that by changing the total number of clusters. If I make it 5, you have more cluster variations to make the island a bit smaller. Now, what I don't like about this right now is that the edge looks a bit too hard in these areas. So in order to fix that, I could use this smooth node right after I have create the resample node before projecting to the original surface. By using the smooth node, you can start to see the smooth node is starting to act, making a smooth edges, especially where it dissolved the unnecessary edges or connecting edges between the cells, creating this kind of a smooth island. And if I do the ray node and if I look at the final shape, it looks more smooth. Let's check without and with the smooth. You can see the difference. Smoother. Having smooth looks better, I think. Now we can go back here and also control the shape to make it more inflatable. Yep, looks nice. Maybe a little bit less to this one. Okay, it's up to you. Okay, looks good. Okay, now I am going to make this visual a little bit better. First of all, by making the shading to a matte cap shaded, which you can use the the matte cap textures of your choice for the preview. I'm just using some random matte cap textures that I download from the web. You can search for a Google image or anything with the matte cap keyword, and then you can get this kind of circular image, and by setting this image to a matte cap textures on the display option here, you'll be able to show this as a matte cap shader textures when you make this as a matte cap shaded. Looks pretty. More easy to see the normal direction. And you can check how the final rendering might look like. Okay, looks good. Now, one thing I could make an update to this one is to make the movement a little bit smoother, because sometimes there are too fast jump between the node between the shapes, such as from here to here, maybe. Well, that might be okay. I mean, doesn't look that bad, I guess. Yeah. No, it doesn't look that bad, I guess. So maybe I don't have to do like special things for this one. It's what I want to do. What I want to try next is to use this for like other geometry other than spheres, and see if this still works. Now let's also change the number of cells to see if it still can be used. Yeah, looks good. With the okay, I think we can also bring this cluster total number of clusters to the controller. Okay. Somewhere around here. More clusters you have, more smaller island you get. Like that. Okay, and I would like to have more okay, it's a hard to control here. I want to have more space in between. Somewhere around here, I guess. Right. Okay. Good enough, I guess. Alright, so let's try to have this to a custom geometry rather than using as for a sphere, and see how it will look like. Okay, so let's create the switch node to switch between the geometries. And let's try with the Voronoi. Let's make this a little bit bigger. Maybe that's too big. Something around here, something around this. Now I think it's a good idea to make this as a one single, like one connected smooth shape, rather than just using the original shape as it is, because the original Voronoi geometry is being constructed with several connected primitives. So you have really like high peak normal directions inside, inside somewhere around here, and so on. So what I'm gonna do is to convert this into VDV first and make this back to a polygon by making it as a single geometry. So not this one, VDV from polygon, and make this back to a polygon. Now the resolution is not enough, so let's make this 0.02. Now I start to see the edges here, so might be a good idea to subdivide before converting to a VDV. Okay, a little bit better. I think this one is fine. Now this is a bit too small still, so let's try to extrude this. Let's try to inflate the whole geometry a little bit more using VDB reshape, using the delayed with offset of 2 or something, which still looks like a Voronoi, so looks good. How about 3? Maybe 2 is fine. And this looks nice enough. Now after I've converted into a geometry or a polygon, I need to check how many points I have. And since it consists a square shape, might not be good in order to move the points on normal direction, but let's check how it's gonna look like. So if I change this to shape, and let's see what happens. Okay, now I have like exploded like shape. Looks still interesting, but I do see a little bit of problems on those those points. That is because it's trying to move the square faces, so I'm gonna make this triangulated, either using remesh or either using divide node. Maybe divide node is fine, not sure. Maybe not, because the shape of the triangle is not so clean. Yeah, not so clean. So let's use a remesh instead. Defining the target size to really small. Maybe that was too small, 0.02. Yeah, good enough, I think. And going back, now I am starting to see some stuff that I would appreciate. Now there are a lot of intersections still, I don't know if we can fix this because this is due to the high curvatures on some of the positions, so maybe it's a bit hard to fix those. But let's see if we could do that. First of all, let's reduce the initial mountain value, or reduce this value here. See, okay. Wow, it's pretty hard to control here. And it's inflating too much, I think. Oh well, it's pretty hard to control here. Let's check with the matte cap shade. Right now, what I could do in order to fix those like two hard edges is to apply some additional blur to some of the informations, like the normal direction of the surface right here coming from this one. Maybe I could add an additional attribute blur for the normal itself and see what it does. We'll make a bit cleaner edge, but losing these details, so maybe I don't really like it. Okay, let's see. This is the initial. If we make it linear, and if we could inflate this. Let's check out how it looks like for the distances. Like that right now. And if in the initial mountain shape without the colors, let's see how it looks like. Maybe it's a bit too smoothed out. So what we could do is to go back to this attribute blur, make this blur a bit smaller, like 5. Then going back to the mountain, it's inflating too much, and make this lower. Will give you a bit better result. Seems like a bit better result. Interesting. Okay, might be better. Let's check. Yep. Well, I still have some problem here with the quality. For those, maybe I could still use this normal, but not too much. Just like that. Maybe that's okay. Another idea I would have is to right now I have two like sets of mountains, but if I like continuously doing the mountains over and over again, that might be also interesting. Shall we try that? I'm gonna test that out by using the for each number. Make it as a feedback loop. I haven't tried this one before, so I'm not sure what's gonna come out. And connect this mountain node. Together with the normal direction. Or I could just make it here. And do I need this? No. And for the mountain, I'm going to remove the parameter link because I want to test it out. Let's make it small move. Let's see how it gives the result. It looks nice. And if I increase the loop, we'll just increase and increase, but using the same rule here. Nice. Nice. Yeah, it looks pretty nice. In this case, you have small number of parameters. You just need to control one, like ramp parameters was one movement plus how many feedback loop you want to have. And you still get the nice result. That looks fine. Yeah, I'll do this way. I'll do this direction. Yeah. Nice. Alright, so I'm going to update this parameter set. I'm going to remove all these and remove all these, and instead I'm going to use this one. So a moving parameter, moving parameter, as well as the ramp parameter and the iteration number. So mountain move, mountain move, ramp, mountain ramp, and mountain iterations. How's this? Okay. Yeah, looks pretty nice. And if I change this shape to sphere, still works. Nice. And if I don't like these edges, the detail of the edges, I should be able to control it by controlling these curves somehow. Starting to get some dithers. Yep, looks nice. Like it. Alright. Love it. And I think everything is pretty much done here. If I make the number of clusters small, you have more connections between the cells. Cool. Like it. I like it. I think I might, like, for the sphere, I can make this smaller. And okay, one thing I forgot is to have a distance attribute blur as a parameter. Maybe I can use this as a parameter as well. So where should I put this? I can just put it right here. Distance blur from 0 to maybe 20 or 50, 40. And let's see the difference. If I change the distance blur, yeah, nice changes. Makes sense to have it as a parameter. Okay, I think there's one thing I don't like. There was a part, you see that the whole height changes from here to here. That is because I am using the attribute promote to get the maximum distance, but this maximum distance changes over time, and by doing that there is a chance that I have this jump between the height, because every frame the maximum height is different. So I think it's a good idea to make the maximum height, maximum distance always the same for every frame. So I can just calculate the maximum distance for the first frame, then use it for whole frame. How's that? I think that makes sense. Yep. So let's do that, shall we? To do that, in order to just calculate the maximum distance for the first frame, I can just use the shift, time shift. And for right after I calculate the distance, I'm going to make the frame value to 1, so that for the output of this time shift always get the first frame result of this dist. And what I want to do is just transfer this distance value to the original flow. So attribute Wrangle for detail, gonna refer to the max distance from the second input. And update your own. Alright, let's see. Do I see a jump? Not anymore. Alright, let's go. So this animation, it's going to be much smoother in terms of the height. There's no jump between the height. Alright, looks nice. Okay, I was forgetting to check the comments. Thanks for all the comments. How do you move like that? Okay, wait a minute. Well, the way I'm moving, what's this? The way I'm moving right now is to use this the 3D mouse from 3D Connection. I think it's called as 3D mouse, which you can use to navigate the space three-dimensionally. And just BDB again. Yeah, using BDB to make it smooth also makes sense, but it's a bit slow, I guess. Obviously, he's not from this planet. Stuff could multiply down the move distance much each iteration, maybe. Oh yeah, that's one thing you could do, I guess. So for each iterations, oops, maybe check the current iterations. Based on this iteration, then maybe a total number of iterations. Let's create the value f and dividing the iterations by the number of iterations to normalize this value. And based on this f value, I could maybe lower the movement. Okay, I already have f, so let's make this t. Multiply by t. As a result, you're getting smoother and smoother. Oh wow. Not sure if that is... looks interesting. I think it might be a good idea to control this t value based on some another ramp parameter to make it interesting. So t... I'm gonna fix this part later. Yeah, I don't know what's happening here. Let's do it. Okay, so I have another ramp parameters, and by making like this shape, it's same as before, just adding the movement on each iteration with the same value. So this is the result. But if I change this to linear curve, you are making the value from smaller to bigger, from 0 to 1. If you make it other way around, you're making bigger to smaller, which also creates some interesting shape. So as a variation, this could be a very interesting parameter to add. So let's have this promoted to the controller. Okay, how do I name this? Mountain iteration ramp. No, it's not correct. I mean, mountain. So this one is, the first one is mountain shape ramp, or inflation lamp. The second one is moving distance ramp, so speed, let's call this speed. Okay, and let's have this like this or like this. Okay. Now let's fix this one. What's happening here? What is happening here? Seems like there's a small island here, so maybe that's the reason. Let's check the curve. Nope. 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 Okay, let's lower the iterations and see what's happening. Okay, there's some problem here. What's this? I am having the same problem from the first iteration, so something must be wrong, and I may need to normalize in the last. Okay, let's see what's this. Let's check the distance value, distance color value. Going back to the shading. Doesn't look wrong here. Is it? Is it because of this one? Is it because of this time shift? Might be possible. If I get rid of this time shift, okay. I'm now having a result that I need. So what's this? What's this about? If I check the max distance, okay, now I know it. It's happening because some value goes over the max distance that I set in the initial value, and because of that it clamped back to 0. So I need to set some clamping to this thing here. So this is where I'm normalizing the value, and there is a possibility is that this becomes higher than the original D. So in order to fix that, we just need to clamp this in between 0 to 1. No, I mean this could be smaller than D, will make this F becomes more than 1, and that will be a problem using the ramp. So yeah, this will fix it. Alright. That looks fine. Let's go back to the matcap and see the result with different parameters. Now I have so many parameters to control. Okay, it's not doing anything. That is because I don't have much iterations. Oops. There's so many controls, so I don't know what will be the best parameters for the initial stuff. I'm just gonna make it flat for this one. Alright. Everything looks cool, good. No errors, I think, hopefully. And I can also make this blur to make it smoother, or 0 to make it hotter. Ooh, looks like warm. Okay. Okay. So this is what I've got. So let me check the comments. Okay, well, thanks for all the comments. Thank you, Door to Nothingness. It was a really nice feedback. I think it becomes more than that I had before. Yeah, I like the result. Okay, so this is pretty much I got for now, and so let me know if you have any questions or if you have any suggestions. If I could update, I will do. If not, I'll gonna end the live stream at this point and leave it to you. I'm going to upload the files to the GitHub and paste the link to this video description page so that you can play out with yourself by yourself. to make it more interesting, maybe, and let me know if you have done that. I would like to see how this can be updated. Ooh, it's a lot. All right. I think every parameter works just fine, even for a custom input shape. Now these parts should be where the nose is. If you don't like it, maybe you could still add the attribute blur for the normal direction, but overall looks fine. Looks totally, oops, did it too much. Yep. Let's keep this to the sphere shape and save this and share it with you guys. Alright. Okay, so I am not going to upload the texture which is used for this matcap shader, because I don't think it's I don't have a copyright to this, so you just download the image you want to use in terms of the shader and set it right here by yourself. Okay, that's it. Thank you for watching, and if no questions or anything, I will end it right here. Thank you, and as always, I am going to upload the files so you can download it, and the video is going to be recorded. You can watch it later from the same URL. I'm also using the Patreon, so if you are kind enough to support me, I'll be appreciated. Okay, well, that's it. Thank you very much, and hopefully I'll be able to do something new next week as well. Okay, good night, and see you next week.